see that, or does it need to be something else? Get white. Better. And we could get a lot more done if I don't have to draw the picture. So if we can skip over some of it, might be better off. Knowing that this is a parallelogram, what do you know about the diagonals? Don't say they're congruent. The two diagonals, what do you know about them? Look in your notes real quick. They bisect each other. So what do you know about this part and this part? They're equal. So what equation can I set up there? Now, if somebody will solve that for x, that'll save some time. What do I know about these other two parts? They're equal, so tell me what equation set up. Y plus 23 equals negative 4y minus 2. I'll solve for y, somebody solve for x, and that way we can move a little quicker. It's 5y plus 23. My pen would work. It's negative 2. Subtract 23. 5y equals negative 25. Divide by 5. Y equals negative 5. All they wanted you to do was find x and y, right? X equals what? Negative 2. So those are our two answers. Next question. None? On 430? Number 3 gives us a graph. Need to change that one slide so I don't have to keep changing colors and wasting time. It says use the distance formula. We got r is negative 1, 0. That's r. 3, 0 is s. 2, negative 3 is t. And u is negative 3, negative 2. If I graph something wrong, please tell me if I didn't count right or something. We want to decide whether that is a parallelogram or not. So we're trying to decide whether that's a parallelogram, and they said use the distance formula. So what you're going to be doing on this is finding the length of all the sides, and what do you know about like segment RU and segment ST if it is a parallelogram? What should be true about their lengths? They should be the same. So if I'm looking at this, and if I graphed it right, it doesn't look like a parallelogram, does it? So what I would probably do is pick out the two sides that I think, well, that one looks a lot longer than the other one, or so what I'm going to do is pick out these two, because if I prove that those two aren't the same length, then we can stop right there and say it's not a parallelogram. Well, for RS up here, the nice thing about segment RS is it's a horizontal segment. How do you find the length of it? How long is it? So RS equals 4. Now for UT, it would have to equal 4 also. I use the distance formula on it. Have your calculator out so you can help me out here. I'll write in the points real quick for U and T. Let's see, U was what, -3, -2, 2, -3. Distance formula is right over there. It's written on the side of the board over there. Don't let me forget at the end of class today, there's a quiz on Moodle. That was supposed to be part of your homework last time. I keep forgetting to tell you guys. Don't let me forget to make it part of it tonight. What's our x coordinates this time? So -3 minus 2 squared. What's our y coordinates? -2, and it's going to be minus a -3, so what's going to happen there? What's -3 minus 2? Be careful. -5. -5 squared is what? 25. Good, I didn't hear -25. What's -2 plus 3? 1. What's 1 squared? Just 1, right? 25 plus 1. Somebody tell me what's the square root of 26? 5.09, so 5.1. What's that tell us about those two? Not the same. So, what do we know? Not parallelogram. Next question. Got to be able to do all that stuff. They give you 3 different ways on there. They want you to use the slope formula, distance formula, midpoint formula. Probably on a test, I would let you use whichever method you want to use. So if you like the distance formula better, then use it. If you like the slope formula better, use it. Probably on a graph, slope's probably the easiest because you can just count rise and run. I look right here on these two, they'd have to be parallel to each other. Well, if I count, I go up 2 and over 2. So my rise over run is 2 over 2, which is 1. On this one, I go up 3 and over 1. So my slope is 3. Are those slopes the same? So are those 2 lines parallel to each other? No. So slope might be a little easier, a little less work. Next question.
Number 12 on 426.
12 on 426. Skip that one. You can mark it out. I don't care about that proof. Number 12 on 426. Next question.
Um, 8 on 426.
8 on 426. All right, watch on number 8 because this is one of those problems for 6 through 9. I won't actually answer the question, but we'll go through and we'll find everything that we can find in the shape, and then you should be able to answer the question. You should be able to answer all the questions for it. If I could draw very well there. That angle's 30 degrees, that angle's 25 degrees. This is R, this is U, this is S, this is T, B in the middle. This is 4B, 4 little b minus 1. This side over here is 23. What's something that we know right away? This is a parallelogram. Give me something that you know. UTR, 25 degrees, good. Those two have to be the same, right? They're alternate interior. How about that one? 30. Let's go back up here. If you know that this is 25, this is 30, how much is that whole angle there? How could 55? Can you find this whole angle down here? 55. What do you know about this whole angle and this whole angle down here. That should add up to 180, right? So if that's 55, how could we find this whole thing down here? 180 minus 55, somebody grab their calculator, help me out there so I don't have to do any math. What is it? 125. If that whole angle is 125, what's this whole angle over here? Because opposite angles have to be congruent, right? We can't really tell what each of these two smaller angles are because the angles aren't bisected or anything else. So we need some more information. Like if they told us one of these middle angles, we could find it. What's the only other thing we can really find here? What do you know about segment RU? It's congruent to ST. So what equation can you set up? That should equal 23. If I solve that real quick, add 1 to both sides, 4b equals 24, divide by 4, b equals 6. I think that's about all we can find. Can you answer all 4 of those questions on that part? Give you a second or two. We don't waste a whole lot of time, but should be able to answer each one of them. Next question. You ready to ask it? Everybody got all that so I can erase it? Yes, no, maybe? Next question. 7 on the last page. We know about opposite angles in a parallelogram. Congruent. So do I need to draw the shape? Let's try to go a little quicker. Tell me what two things have to be equal to each other. Five x plus 29 equals 7x minus 11. Somebody solve that for x. What's the other equation? I'll solve the one for y. So opposite angles, this angle and this angle, opposite angles have to be congruent, right, for every parallelogram. I'll solve for y, somebody solve for x, that way we can go a little quicker. It's 2y minus 9 equals 15. Add 9 to both sides. 2y equals 24, divide by 2, y equals 12. So that's half your answer. What's the other half? 20. Everybody agree with that? Anybody know how I could get this slide not to be this stupid thing without changing the whole slideshow? It didn't work. As soon as you change the color, it changes the whole slideshow.
Yeah, there's certainly, you're supposed to be able to see the group, you just change the
Last page. Next question. The last,
Let's do, we do
8 on the last page. 8 on the last page. We just did 8 on the last page, didn't we?
7.
I thought we did 8 earlier. Oh, that was 10. Sorry. Again, on number 8. What do you know about the diagonals of a parallelogram? What do they do to each other? They bisect each other. So tell me one equation we could set up so I don't have to draw the picture. Somebody solve for x and figure that out, and I'll do the y. What's the y equation we could set up?
3y minus 5 equals 2y plus 8.
Here we're going to subtract 2y on both sides. You end up with y minus 5 equals 8. Add 5 on both sides. Y equals 13.
X equals
Negative 6. Everybody agree with that?
6.
Diagonals in a parallelogram bisect each other. Opposite angles congruent, opposite sides congruent, opposite sides parallel. Got to know all those properties. Now, do I expect you to have them memorized? No, what I don't see right now from any of you is probably what should you have out. That's true, but you all have that. Your notes probably, right? Have them open so you can see those properties so you can, oh yeah, those got to be the same. Give me the next question. How much time we got left, Dave?
2 minutes.
Better hurry up. Yes. 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 Sure.
13 or 426.
426, number 13. Number 13. I'm not going to read that whole thing. You could read about Mr. Rodriguez there if you wanted. He's trying to do a sidewalk. You ever seen these sidewalks where they try to make them fancy and they make them parallelograms instead of rectangles or squares? They figured out that the measure of angle 1 right there is 130 degrees. We want to know the other angles.
The one across from us is 130.
So this one down here is 130. Which angle is that?
3.
So angle 3 is 130. This one's 50.
So,
That one's 50. Those are your 3 angles. Real difficult problem? No, you just gotta remember those 2 rules. Opposite angles are congruent, consecutive angles are supplementary. Next question. You guys haven't given me a hard one yet. There's a few hard ones on here. Haven't done any of them yet.
6 back.
6 on the back page.
Yeah.
Probably need to graph it, right? It says determine whether each figure is a parallelogram. Use the indicated method. Number 6, -2, 5. White's probably not going to work, is it? Uh, 1, 3. What was this? This was R. This is O. This is M. -3, -4. And Y is -6, -2. They said use the distance and the slope formula. So what we want to do is pick 2 sides. And remember, to prove it's a parallelogram, if we can show that these 2 sides are parallel, go ahead and turn it off, David. Show that these 2 sides are parallel and that they're congruent to each other. then it's going to be a parallelogram. So we just need to pick two sides. So pick me a side. I would probably pick the shorter sides to make it easier on counting, right? RO. So to find the slope of RO, we just go up and over. How much did I go up? 2. How much did I go over? Be careful. -3. So the slope is -2/3. Do the same thing down here. Y to M, how much did I go down? -2. How much did I go over? What's that tell us about those two? They're the same, so we know that those two are parallel to each other. Now what we're going to do is use the distance formula to find the length of each one. All right? So let's do this one first. Somebody help me out and we'll try to get another problem in here, even though the timer went off. For R and O, looking at your paper there, what's the x coordinates of R and O? 2, -3. So 2 + 3 squared. Make sure everybody's looking, because if somebody tells me wrong, I'm not, oops. Yeah, that's right. If somebody tells me wrong, I'm not going to know. What's the y coordinates for R and O?
Are we doing number 6?
Yeah.
It'd be -2, 1. X is.
For R and O?
Yeah.
Tristan, you lied to me.
Yes, it did. -2, 1.
So -2 minus 1 squared, what's the y coordinates?
5.
Say it again.
5, 3.
5 and 3, so 5 minus 3. Somebody figure out that math and we'll go ahead and we'll do this other one over here so we got more time. Figure out what all that is, what the square root is. Now tell us how long segment RO is down here. For YM, if I'm looking at Y and M, the x's are -3 and -6. So -3 + 6 squared. And the y coordinates are -4 and -2. So -4 + 2 squared. I'll do this half. That gives me 3 squared is 9. -4 + 2 is -2 squared is 4. Those two add together is square root of 13. So the length of this one right here is the square root of 13. I'm not even going to change that into a decimal. What should the length of this one be?
36.
Square it. Go back a step, because I didn't change mine to a decimal. What was the square root before you?
36. 13.
13? Anybody else get 13?
Yeah.
Let's do it real quick just to make sure. What's -1 minus 1?
-3.
-3 squared? No.
Negative.
Positive. 9. Negative times a negative is positive. What's 5 minus 3?
2.
2 squared. 9 plus 4. 13. Now you could change those to a decimal, but all we really cared about this time is whether they were the same or not. Were they the same? So could we stop right there before we have to punch it into the calculator? Yeah. So if these two sides are congruent to each other and they're parallel to each other, what do you know about this shape? What's that tell you about it? Yes is a parallelogram. Give me one more. Quick one, because I wasted a couple minutes trying to change the slides. No others? 5 on the front. 5 on the front. They tell us that that right there is a right angle. This part right here is 12. This angle is 3x. I'm not sure why they put this in there. I guess they thought you guys were idiots. So they told you that these two angles are what to each other? Did they need to tell you that? Hopefully everybody knows that those are vertical angles by now and that they are congruent, right? I guess maybe they did it so that they could show you that that angle is also congruent to those. They tell us anything else that I missed? If this angle right here is 3x, what's this angle? What kind of shape do you have right here? What do you know about the three angles of a triangle? Add up to 180. So how could I set up an equation there? Simplify that for me. Now what? Subtract 90 on both sides, right? Grab your calculator for me. 6x equals 90. What do you do next? Divide by 6. What's x equal? What they ask us to find? X and y. So we found x. That's half our answer. Now to find y. Let's see here. If we take that and we plug it back in here, what's 3 times 15? 45. So that angle right there is 45. What's 3 times 15? So what kind of triangle do you have right there? So 45, 45, 90, isn't it? I'm going to split it off. Remember, in a 45, 45, 90 triangle, this is one of the harder ones because you had to remember back. In a 45, 45, 90 triangle, the sides across from the 45-degree angles we labeled L and L, right? Side across from the right angle, L radical 2. Well, we don't know, this is our L here, and this one up here is our L. What's L equal then? 12. So we know L equals 12. If L equals 12, and we're looking for this, because what do you know about those two parts? If that's 2y, what's this part down here? 2y. So we know that 2y should equal what? Shouldn't equal, 2y shouldn't equal just 12. It should equal 12 times the square root of 2. How do you think you solve for y there? What if I got rid of the square root of 2? How would you solve for y? Guess what you're going to do if it's there? Divide by 2. Easiest way to do this one, what's 12 divided by 2? I just leave the answer that way, 6 times the square root of 2. Could you change it to decimal and like use Pythagorean's theorem to find it and something else? Yeah. Probably a little more headache. All right, make sure your names are on those. You can lay them right there on the little table. Yeah, hurry.
Hi, kid.
Number 3.
Shouldn't she have started the time just now?
We can get quite a few done if you're paying attention, asking questions when I ask you to, and I think my first class, I think we got like 10 or 12 done, and they don't always stay focused as well as they could. And some of the problems, if I don't have to draw the picture, if we can just set up the equations without me drawing the picture, because you see drawing the picture takes quite a bit of time, right?
Yep.
Let's see.
We can draw one for you, like ahead of time, draw one.
So we have this, and trying to think if What do you know about these two angles, the 2x and the 4y?
They equal the same thing.
They're equal to each other, right? Now, if I draw this triangle, I'm trying to figure out a way to do this with all the stuff that you know right now. I think this might be one of the problems that they stuck on here that I never could figure out how they wanted you to solve it because you don't have enough knowledge yet. If I draw this triangle, what kind of triangle is it? So if this angle's 2x, what's this angle up here?
2x.
Now we have that. See what else we can do here. We also know that this angle down here, we said that was 4y.
4y.
This is 4y, and we said really the 4y is also 2x, right? They have to be equal, so that has to be 2x or 4y. So once we know that, right here we have, I guess if we're just finding x and y, we don't need all that other stuff. What do you know about this whole angle and this whole angle? Those two angles. What do you know?
Equal the same measure.
Consecutive angles. What did it say in the properties that we covered last time? What do you know about consecutive angles?
They add up to 180.
They add up to 180. So, let's see if we have enough here, because we need to know this angle also, which we really don't know yet. Trying to think what else we could know here. So if we knew this part right here, we could set up that equation.
Yeah, so can we just mark this as
But
unsolvable?
aren't those two angles right there complementary? Yeah.
If these two angles are congruent, guess what's going to be true about these two angles?
It's 60.
So that's got to be 60. Now, what do we know about that whole angle?
Equals to 180. Oh, 120 I meant.
120.
Which means the other one has to be 60.
So this angle has to be 60. Now what equation can we set up?
2x equals
2x
2x plus
2x
2x equals
60.
60.
So 4x equals 60. And then 60 divided by 4 equals 15. So x equals 15.
Now what'd you tell me about 2x and 4y? They were the same. So, well, we now know that x is what?
15, so we can just plug that in, which means
2 times 15.
30.
So 4y has to equal 30. How do you solve that? What's y equal? 7.5, 7.5.
Is that our answers?
Yep.
Nice. Number 4, please.
Now, this one's going to be a lot easier later on in the chapter because you're going to be able to say, hey, that shape's not just a parallelogram. If it's got 4 congruent sides, it's going to be another special shape that we're going to talk about, and it's going to have other properties. So if we see this, if we see this problem later on in the chapter, it won't take near that much work. Because if I see this problem with all the stuff I know about 4-sided figures, first thing I would have done here, that right there has to be a right angle. All right? You didn't know that yet because we haven't got to that shape yet. So we had to go sort of the long way around it. And Chloe's looking like, well, how do you know that? Well, I know that because whatever this shape is that we haven't covered yet, I know the diagonals are always perpendicular to each other. You don't know that yet, though. You'll know in a few days.
Alright, number 4.
We did number 4 last class.
Did we?
5.
I thought
It's
that-
x equals 3.5, and then y equals 10, and with the radical 3.
Next question.
5.
Okay, thank you. I didn't have that, so I didn't.
5 where?
Conversation. Is what 3 1 is about.
Easiest thing first start with, If this is 3x, what's this angle over here?
3x.
What's this angle down here?
3x.
What kind of shape do we have right there? What do you know about a triangle?
Side is 180.
3 angles equal 180, so could we set up an equation?
90 plus.
Oh, wouldn't that be 40, they have to be 3x.
3x equals 180.
Now what? So 6x equals, then what?
Divide by 6.
What's x equal?
15.
That's one of our answers. If we know x is 15, then how much is this angle right here?
45.
How much is this angle?
45.
Yeah, that's very high also.
Now watch what happens here. If I look at this triangle, if I was to separate off that triangle, even though my picture looks absolutely nothing like it, what kind of triangle is it?
Isosceles.
It's an isosceles triangle. It's a 45, 45, 90, right? So in a 45, 45, 90, we know the two sides across from the 45-degree angles, you gotta remember all this stuff that we've covered this year, should be labeled L and L. Side across from the right angle should be labeled L times the square root of 2. So this side right here should be L radical 2. This side should just be L. This side over here should be L. Well, what do we know about L? L equals 12. I don't even know if that'll help us or not, but we'll figure it out here in a minute. What do you know about this triangle right here and this triangle over here? They're congruent to each other. And actually, we could do it that way and figure out stuff about this triangle, or the diagonals bisect each other. So what do you know about that segment and this segment? They have to equal the same thing. So if that's 2y over there, what's this one? 2y. We know what L is. What was L? L was, so this is, length of that's going to be 12 radical 2. Could we set that equal to the 2y right there? So 2y equals 12 radical 2. Let me cover this up. If you had that, how would you solve it? Divide by 2. Guess what you do if you have that? Divide by 2. Same thing. It doesn't change. So we divide this side by 2, divide that by 2. What's 12 divided by 2? Give me another one.
6.
If I got that so I could erase it. That's a right angle. What's this angle right over here?
Right.
What kind of triangle do we have right there? It's a right triangle, isn't it? If we have that right triangle, we know this side is how long? 17. We don't know this side. We sort of do, because this part has to be 4, so that has to be 8. Can we find that side over there? Now, a lot of you are looking at it like, why do I want to find that side over
I
there?
got you.
Well, what do you know about these two sides?
That they add up to the square, a square plus b.
They're congruent, those two sides, right? You're ahead of me, Katie. These two sides are congruent, so if we find this side, that's going to be the same thing as x, right? So that'd be finding x. Now, Katie, you can use Pythagorean's theorem, correct?
Yep.
So tell me how to set it up.
17 square root, which is 289.
Tell me how to set up Pythagorean's theorem, because
A
you.
squared plus b squared equals c squared.
Tell me how to set it up with our numbers.
X squared.
A squared plus x squared equals 17 squared. Now, I wouldn't even do Pythagorean's theorem here because this fits one of those families or those Pythagorean triples that we talked about. Does anybody remember what this third side has to be if one leg is 8 and the hypotenuse is 17? If not, then could you do it that way and figure it out? Somebody figure it out because I don't want to do Pythagorean's theorem. Just 9? I'm gonna write it 10. I'm just gonna write down any answers that you guys are yelling out, and if it's wrong, it's wrong. When I collect the paper, I'll mark it wrong.
Well, I just,
Somebody do the math. Do the math down here. You guys know how to do Pythagorean's theorem. Or look up the triples. It was one of the 5 easy ones that we talked about.
Yeah, that's what I just know we want to say it.
Can you read your writing?
Yeah.
What's that number?
15.
Okay. So we know x is 15. Now we want to come over here and find y. That means this side right here is 15. What kind of triangle do we have right here? Right triangle. We know this side's 15, this side's 4. How long is this part over here? Y. Could we do Pythagorean's theorem again?
Yeah.
Tell me how to set it up.
4 squared.
Plus 4 squared equals 1 squared.
Somebody solve that. Figure out what y is. I'm not doing Pythagorean's theorem for you guys because everybody's sitting here like,
14 point something.
what is it?
14 point something, I think. I don't want you to write that.
15.5.
14.5.
Yeah, I got 14.5. Hey, I got 14.5 also.
There's like 6 different answers now.
What would I?
4 squared is 16, 15 squared is 225. And then you
4
subtract
squared plus
16
That's exactly what I
from
said.
225.
No, you don't. You don't subtract. They're on the same side.
Oh, 4 squared
Hey,
plus
but I
15
want
squared is
mine.
251, and then you take the square root and 241, and it's,
Okay,
okay, they're right, they're right.
What is it?
It's 15.5. Sorry.
Come on now. Pythagorean's theorem is supposed to be one of the easy things.
Hey, I didn't what Sherry said though, but.
Yeah.
Next question.
Oh, I got you. Number 4.
Number 12 on the third page or on the second page.
Yes.
You can mark it out. I'm not even gonna count that.
Okay, number 13. 13.
Well, that one was easy.
Oh, fine. Number.
Yeah, it was very easy. You just
That
had,
one was
you
easy.
just had to read. Next question. Do you want me to do 13 or not?
No.
4.
10.
Wait, yeah, and 4 actually.
4 on the second page?
4 and 10 on the second page.
Okay. Sorry.
Angle NL, or no, NPL, so that's this angle, is supplementary to, and they want you to name the other angle it's supplementary to. Let's put in the other letter up here. What kind of angles are supplementary in a parallelogram? Consecutive. So we're dealing with this angle, we want to name an angle that's consecutive to that one.
And well,
You guys make things harder than they
Now
have to
10.
be. Which one?
10.
And 11.
Yes.
And then.
You guys haven't noticed yet that I refuse to take 2 requests at one time?
okay.
Yep.
We're just letting everyone else know. We gotta
So-
do some next one.
Alright. As long as you're not letting me know.
Yeah.
2, 5,
Is the R is 3, 3. The Y is -2, 3, -3.
-2, -3?
Yes. Z is -3, -1.
They said find the coordinates of the intersections of the diagonals of this parallelogram. So, what do you know about the diagonals in a parallelogram? What do they do to each other?
Bisect.
They bisect each other. So when we find the coordinates of that point right there, what should it be? What should that point be to this diagonal? Should be the what?
Midpoint.
Midpoint. Guess what formula you use to find the coordinates of it? The midpoint formula. Doesn't matter which one you use because they should be the same.
Wait, so like P and Y?
You could use P and Y, or you could use R and Z. Right? Midpoint formula is right on the board over there. Are we going to use P and Y? Is that the ones you want to use?
Yeah.
All right. Tell me the x coordinates for P and Y.
2 and then the 2.
2 plus -2, that's divided by 2. Tell me the y coordinates for P and Y.
5 and -3.
5 plus a -3 divided by 2. I hope Teresa's telling me right. I mean, or somebody's checking to make sure because I'm not paying any attention to the paper. What's 2 plus -2?
0.
0 divided by 2. 5 plus -3.
2.
2 divided by 2.
0.
1.
1.
Oh my gosh, I got that right.
If we did it the other way, if we use Z and R, guess what we should come up with? 0, 1. Same thing. They should come up. If you were actually trying to prove that this was a parallelogram, then that's what you'd want to do. You'd want to find the midpoint of ZR, the midpoint of PY, and they should be the same. Next question.
Number 1 on page 3, please.
Wait, what?
I don't have your stuff.
Number 1, is that what you said? This is like the first thing I'm doing right now.
We're trying to prove that this is a parallelogram by using the slope formula. Well, I wouldn't even use the slope formula on this since I graphed it. I would just find the slopes just by rise over run. First, let's do BC. What's the slope of BC? What's special about it? It's horizontal. What do you know about slope of a horizontal line or segment? 0. Now, BC should be have the same slope as what? AD. Well, what do you know about the slope of AD? It's the same. So what is it? 0. So we know those two are parallel. Now, does that tell us it's a parallelogram? No, it tells us these two are parallel. What else do you have to do? You gotta do the other two sides. Find the slope of the other two sides. What's the slope? Let's find the slope of AB. Not as easy on this one. You gotta count. Rise, run. How much did I go up? How much did I go over? So slope is 3. And then the other one would be DC. How much did I go up there? 3. That's our rise. How much did I go over? 1. Slope is 3. What's that tell us about those two? They're parallel. So we now know that these two are parallel. Those first two were parallel. So from all that information, now what can we say? So it is a parallelogram. If I could spell. Not a 2-column proof, but do you see how you're proving something? You got to go through and you got to be able to explain to somebody, hey, these two slopes are the same, so those lines are parallel. These two slopes are the same, so those are parallel. Since both these are parallel to, both pairs of opposite sides are parallel, then we know that it is a parallelogram. Remember the flow charts that we didn't do throughout the year? This is sort of a flow chart right here. If I put little boxes around it, that would be like a flow chart that we said we weren't going to do. I'll do one more.
7.
7 where?
4:30.
Parallelogram has vertices. Find all the possible coordinates. I did my thing not erased. It's got vertices, -2, -1. That's R. It's got vertice, or vertex 2, 1. That's S. 0, -3. That's T. They want all the possible other points that could have here to make that shape into a parallelogram. So we have those 3 points. Does anybody see anywhere where we could come up with another point that would make it a parallelogram? You don't have to give me the coordinates, just sort of tell me an area. Or come up and point at it real quick. This way? Here? So you think right in there maybe? Is that gonna make it a parallelogram? Looks close, doesn't it? How could you maybe find it? You guys are in the right general area. What do we know about S connected to this? Should be the same as R connected to T, right? So could we do our little slope thing there? Goes down 2 and over 2. So would that work? Yeah, it looks like it. So that's one of the points. What's the coordinates of that point? 4, -1. So that's one of them. That would make it a parallelogram. Is that the only one? So nowhere else on here that would make it a parallelogram? Here? Right there? Let's look at it and see. Does that look right? Maybe over 1, so right there? Here? That would look like it would make it a parallelogram. Could we do the same thing? We go here, up 2 to the left 2. What should we do from there? Up 2 to the left 2. What's the coordinates of that? 0, 3. So that will work. Are those the only 2? How about down in here somewhere? Would one down in here work somewhere? I don't know, let's look at it and see. Let's go from S over to R. Should be the same thing, T over to this other one if it's going to work, right? So 1, 2, 3, 4. Is that going to make it a parallelogram if I connected that? Would that be a parallelogram? What's the coordinates at that point? Count for me.
1,
No, wait till I move.
1, 2, 3, 4, 5.
I said 5.
You said like 10 other things also.
I said 7 and then I said
P
5.
could go from, take P over 4 down to,
Over 4,
no.
This
no,
way?
I'm wrong, down to 2,
so over 4, down 2 here.
yeah, I'm wrong though.
It'd be over 4 and
Or,
up 2, which puts us on one that we already have.
oh, take 4.
I think that's all of them.